All right, so we are going to pick three different bases. We are starting with base 10. Then we are going to use base 2, base 5, base 8. Then we're probably going to write the numbers we know. So this is the decimal base. And this would be the binary base. Base 5 would give us the quinary base. And base 8 would be the octal base. So we are going to see how we can write different numbers, which we already know in base 10 in the other bases. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in base 2, 0 is always 0, 1 is 1, but then 2 would become 1, 0. We are supposed to combine this. 3 will become 1, 1. 4 would become 1, 0, 0. 5 would become 1, 0, 1. 6 becomes 1, 1, 0. 7 becomes 1, 1, 1. 8 is 1, 0, 0, 0. 9 is 1, 0, 0, 1. So this is how the numbers 0 to 9 appears in base 2. In base 5, we are going to have 0 as 0, 1 as 1, 2 as 2, 3 as 3, 4 as 4. Then 5 would appear as 1, 0, 6 as 1, 1, 7 as 1, 2, 8 as 1, 3, 9 as 1, 4. On base 8, we are going to have 0 as 0, 1 as 1, 2 as 2, 3 as 3, 4 as 4, 5 as 5, 6 as 6, 7 as 7. Then 8 is would have to appear as 1, 0, because the highest value we can have in base 8 is 7. And then 11, 9 would appear as 1, 1. Now there is the need for an indication to be made for the reader to know of the base in which numbers are written. So in base 2, there will be a subscript here as base 2 for each one of these. So anytime we're writing numbers in base 2, we have to indicate that. It could be in digits, that is figures, or it could be in words, as in base 2, base 2. And it is written as a subscript, not a smaller letter, or a smaller number, but a subscript. So this would be in base 5, base 5, base 5, base 5, base 5, or in letters, base 5, base 5, base 5, base 5, base 5. We are just going to do this as numbers base 8, base 8, base 8, base 8, base 8, base 8, 8, 8. Base 8. So this is how numbers are represented. But now, how was the decimal basis changed to binary, quinary, or octal base? That is what we are going to learn in the next chapter. But what I want us to keep in mind that usually for the decimal base or base 10, we do not write subscript for the bases. So any number you see on its own without any base indication tells us that it is in the decimal base. Okay, so if I should write 5 without any decimal base, and it means it's in base 10. 8 is in base 10, like we always do. So the numbers we've been using since early on in our education tells us that we've been studying numbers in base 10. Okay, now we are being introduced to base 2, base 5, base 8. So what we're going to learn next is we will pick numbers in base 10 and we'll try to convert these numbers from base 10 to other bases. Okay, so that is our next lesson, converting base 10 or decimal numbers to non-decimal numbers. So when you say non-decimal numbers, it could be a binary number base 2, an octal number base 8, a septenary number base 7, so on and so forth. So let's pick some random numbers. Let's say 1982, 2025, 1990. I'm reading them as date. But this is actually 1982, 2025, 1990. Now we are going to convert these to base 2. Alright, and the method we are using for base 2 can be used for any other base. So this is 1982. We are converting this to base 2. So we draw this kind of table, 1982. Then on this part of the table, we would like to put our remainder.